Welcome to Module 2 of IS735 on social media. In this module, we'll be talking about collecting social media data, what that means and what that looks like. So this module has 6 primary learning objectives. The first is being able to describe at least 2 alternative methods for collecting social media data, identify at least 2 ethical issues concerning social media data and its collection, and be able to collect social media data using APIs and scraping tools, differentiate among types of social media data, differentiate streaming and retrospective collection, and then describe JSON and its relevance to data collection. So the primary objectives, the last 3 here, are more technical. The first 2 are more theoretical, and 3 is basically application and practice. So why do we ask this question about how do we collect data? Well, the bigger question here is how do we study social media and social media channels? And there are 4 main questions that we might try to ask. We might be interested in studying the data people post. This is the most obvious thing. So we've seen this photo before, where people are posting different kinds of content in the aftermath of disasters, in the wake of a particular event, to share news and information, to spread public health information, to share political preferences, these kinds of things. So we can study this data that's being shared directly. We can also study how people use social media channels. So we know in the United States, based on some Pew Research and survey work, that a little less than half of the people on Facebook use it for news. This is very different than the people who use WhatsApp and Tumblr, so they don't generally use it for news. We know that people use these platforms for mobilization and for coordination during political protest. And we know that people use these platforms and social media channels to share information about gratitude or expressions of social support in the aftermath of disasters. And for many other things as well, for social connection, to build social capital, advance social movements, all these different kinds of things about how people use these channels and why. We can also study more technical questions about how social media platforms work themselves. For instance, there's lots of open technical questions about how we recommend content to users. For instance, this paper about deep neural networks and how YouTube uses them for recommendation is a very technical piece about how do we get new videos in front of users. But then we have more socio-technical issues, like how YouTube's algorithm for recommendation works for particular kinds of users, and what kinds of impacts these recommendation algorithms have in the world, which brings us to our next question, social media platforms and their impacts. A clear segue from how these platforms work and the behaviors they incentivize and the kind of media that they push to how people engage with them and how these platforms affect the real world is this HuffPost piece about people sharing stories of falling down YouTube's recommendation rabbit hole. The idea being that YouTube is recommending content that's trying to keep people engaged with eyes on the platform as long as possible, without really thinking about what kinds of content that might be. But of course, it's not just a socio-technical issue in that regard. Very recently, a hacker or a collective of hackers were able to breach a number of high-profile Twitter accounts, including Joe Biden. And as a result of this, since Joe Biden is part of the presidential election here in the United States in 2020, stocks in the United States took a hit of about 3% after this hack. And this is not new. Back in 2013, a person hacked into the Associated Press's Twitter account and posted a tweet about there being 2 explosions at the White House, and the president at the time, Barack Obama, was injured. This resulted in a massive sell-off driven by a lot of these automated trading platforms that take news and information from these online spaces and use it to make decisions on trading. And you see here at the bottom of this Market Watch piece that significant dip in market value was a result of this tweet. Now, fortunately, the markets were able to recover very rapidly as this was identified as being false. Now that we've asked questions about what kinds of things we may want to study on social media, we can ask, how do we collect the data from social media that we need in order to observe and make these and answer these questions? So the obvious answer, or probably the easiest answer, is to rely on somebody else who has collected data for you. We can do this in the form of dataset archives. One of the more interesting is probably the Internet Archive, which is a large archives of online content from books, movies, software, music, etc. They actually run the Wayback Machine, which is a really interesting tool that lets you go back in time for a particular website and see what that website looked like at that earlier moment for sites that are no longer available or sites that have since changed their layout, these kinds of things. One of the other things they run is the Twitter Stream Grab, which is run by the Internet Archive's archive team, which is monthly data set of tweets going back to 2011. So like I said, broken up by month. It generally has about 40 gigabytes of tweets per month. Of course, this varies by time, but there's a lot of data here. It has become more spotty over the years, but at the very least, there is some valuable data for the early 2010s. More recently is Jason Baumgartner of pushshift.io. He runs a data set of Reddit data, or the Reddit archive, covering 2006 to 2020, both Reddit submissions and comments, containing literally billions of these pieces of data. Again, you can also view this at a monthly level. His archive has really enabled a huge amount of research in Reddit in a similar kinds of way that Twitter's access and their archives through the Twitter stream enabled research on Twitter. Facebook, on the other hand, doesn't do as much in terms of making archives publicly available. That's kind of changing now with the Social Science One partnership that they announced last year. But still, Facebook is very sensitive to privacy protections of its users, especially given how large of a platform Facebook is. So the Social Science One opportunity is meant for academics and research labs, in particular, who are interested in understanding social media and its relation to elections. They're opening that up over time. There are other archives, of course. So the International Conference for the Web and Social Media maintains a set of data sets that are associated with data set papers that have been published at ICWSM. You can go view their collection of data sets on at least the 2018 website. For whatever reason, the 2020 website doesn't have this, but 2018 does. There's also the Dataverse project, which is now the new way, or one of the new big clearinghouses for papers to publish where their data sets are going. And of course, there's Kaggle, where people can share data sets of any real kind. There's a lot of social media data there as well. But this opens up a lot of interesting questions about whether platforms are actually allowed to share this data. So as I mentioned, Facebook is very concerned about the privacy protections of its users. So they are sort of very hesitant to share that data in a very public way. Twitter, as a primarily public platform, so the platform is meant to be public-facing, it has less of an issue with this because since it's primarily public-facing, but still there are questions about who owns that data. Twitter's response is very much their users. So if their users decide to delete data, you're supposed to follow that and delete data from your archives as well, something we've talked about. And there are questions about GDPR here as well. So if a particular platform is sharing or making their users' data public, is that allowed under the EU GDPR law? And how does this affect things where it's not the platform itself making this data available, but individuals who are going and collecting this data? So like the Internet Archive's Twitter Stream Grab. It's not Twitter making this data available directly. It's Twitter's platform supporting individuals who then collect this data and make this data available. And even if it is legal, there's still this question of whether platforms should do this. Are their users comfortable with their data being used for research or being used for these kinds of studies? There's some research that suggests users are not okay with this, but it's a thing we have to balance and consider. All right, so what if you can't find an archive of somebody who's collected data that's from the platform you want about the topic you want? In fact, this is what you'll be asked to handle, or the situation you'll be asked to handle for assignment 1. So one really easy but very manual way is to just copy and paste content from one of the target platforms into some spreadsheet or into some document. It's very manual, very, very labor intensive and time consuming, but it is a reasonable and legitimate way of doing data collection. Likewise, if you want to get a little bit more in situ about it, you could take screenshots of your computer while you are viewing a particular piece of while you're viewing a particular social media platform. And maybe this is the only real way to do data collection if you're looking at Snapchat or one of these more ephemeral platforms. And we'll talk about what that means in a few minutes. In terms of collecting what you see on your screen through screenshots, you can do something slightly different with scrapers and collect what your browser sees. A really good example of this is the ProPublica political ad collector that was published several years ago. So this political ad collector is a Chrome extension or a Firefox extension that gets embedded in your browser and can scroll through your Facebook feed and look for political ads that you have seen. And if you have enough people install this extension, ProPublica was able to build up this nice database of political ads that were being run, who was seeing them. Prior to Facebook's release of its ad library, this was hugely useful information to understand what political campaigns were running what ads, who were they targeting, etc. Things are a little bit different now, and ProPublica has now released the development of the political ad collector. It's now a platform called Ad Observer that supports Chrome and Firefox that's run by New York University. But still a very pro-social kind of application for understanding ads, especially when we know that what ads I see may be very different than what ads you see. So we can't just look at it from, well, these are the ads that were run on the platform. We want to understand who was targeted in these ads. And there are other kinds of scrapers as well. Twint is a good one that we'll talk about later that uses Twitter and its web environment to scrape and avoid Twitter's restrictive rate limiting, which prevents you from going and viewing potentially all tweets from a particular user or all tweets over time from all time. We'll talk about this more in a few minutes. Another method for collection is survey work, where you survey people about their social media habits or survey people who are on social media. The Pew Research Center has done a lot of this, and they have some really excellent data, not just about social media data or who uses social media, but sort of a whole number of things about journalism and media. They have a lot of work on social media as well. They have an annual social media report about who uses which platforms and why. It's a very useful resource built on survey work, giving us really valuable information like demographic breakdowns about who uses platforms, who uses what platforms. Like here we see very easily Americans of age 65 years and older are generally not on social media, where the majority of them do not have a social media account, whereas people in the age range of 18 to 29, the vast majority of them use social media. But it's not just traditional and well-run surveys that are of interest. Maybe you've seen these kinds of surveys: which Harry Potter character are you? What's your personality? Which Dr. Seuss character are you? And maybe less frivolous or less pop culture-esque is this Gerber Life quiz about testing your financial literacy. All of these are also kinds of surveys that people could take. It turns out these kinds of surveys are pretty engaging, especially if they have a badge or something that you can share on your social media feed. And all of this can be combined with existing survey instruments to understand something about the users of the platforms. But there's a real question about, these users understand that they're essentially giving up a lot of information about their personality or about who they are that maybe they wouldn't be comfortable with if they knew the extent of the way their information was being handled. So should people's data from these kinds of quizzes be used for research? How much information do you have to provide for these users to get informed consent that you're going to use their quiz answers for research? How long do you get to keep them? There are lots of ethical questions here. This is a paper that I've shown before about using social media for recruitment. There's lots of ethical thorns that we have to deal with. We can also talk about the Graph API from Facebook or Reddit's API or Twitter's API, which provides approved levels of access to the platforms that are supported generally by the platforms that allow for programmatic access to the platform. Now, generally, these APIs are meant for people who are building software to either engage with the platform or extend the platform. So, for instance, Facebook apps or Facebook games, or for the Twitter API, getting Twitter integration into your mobile application. or for Reddit, using the Reddit API to post content on your behalf or auto-moderate subreddits, all these kinds of things. Many different platforms have APIs that you can rely on, not just to collect data about the platform, but also to post data on your behalf. All right, so we've talked about ways that we can get data. Now we'll talk about what kinds of data can we get. So we might be able to look at content that people are posting. So these are politicians on Twitter. What are they saying? We can study the content they're sharing to get an idea of how they view particular issues. We can look at content shared by public health organizations like the CDC or public safety organizations like the California Fire Department, who are sharing evacuation orders for the Coral Canyon off-road area during the most recent California wildfires, and then how people are sharing content for political mobilization. This is all the shared data that we can mine in terms of content mining to understand or extract insight. But it's not just that kind of shared content. We can also look at who follows whom. So here's a list of the people I follow on Twitter and also a list of the people who follow me. This is really valuable networking data for building and understanding social networks in the real world. We can look at how people have engaged with or how many people have viewed particular pieces of content. So here, this is the Twitter analytics dashboard for my account, and we see a particular tweet I posted last month had about 2,000 or 2,500 people view it. Only about 100 people really engaged with it. This is, when we say engagement, this is like retweeting or liking or clicking on kinds of content. Now, for me, you can see my engagement rate's very low. I'm some random professor. I don't drive or mess around with my trying to optimize my engagement by any means. But you could imagine political campaigns or public relations campaigns or marketing campaigns would find this information extremely important to understand the efficacy of a campaign. Or an influencer might want to understand how a particular kind of video drives traffic, or whether they're experiencing increases in their audience or decreases in their audience. So like I mentioned, here is an example post from Elizabeth Warren. This post is provided by the CrowdTangle interface, which we'll talk about later on. And you can see down here at the bottom all the different kinds of engagement that people have. So there have been about 3,000 different reactions, 500 or so comments, 400 or so shares. And we see this little 1.8x is a metric from CrowdTangle suggesting that this link or this post was 1.8 times as popular as your general post from Senator Warren. But there are other kinds of engagement as well. So here, this is a Twitter thread between me and a few of my colleagues. So Chris Mazinski, who's a professor up at Syracuse, he posted on Twitter, and I replied to him. We had kind of a back and forth, and then one of our other friends, who's a professor at the University of Delaware, then posted his own comment. And we can here build a different kind of network, not a network of who follows whom, but who interacts with whom, or who's retweeting or replying to or liking whom. So this is what we see on Twitter, but this kind of interaction is prevalent in all kinds of different places. Like here on Reddit, this user GPL89 posts this question to Ask Science, and then is responded to by Aron Katar. And you have different kinds of interaction structures here because Twitter is much flatter. It's not nested in the same kind of way that Reddit is, where Reddit has arbitrarily nested or arbitrarily deep nesting in its comments and replies. So you get different kinds of structures here, but we can all mine this interaction data. If we're looking at social movements, like this piece by Dean Freeland et al. About beyond hashtags, hashtag Ferguson and Black Lives Matter and the online struggle for justice, maybe you don't care so much about two people who are interacting or how many people have viewed a single tweet. You care much more about how large-scale populations are responding to particular events. So here is a really good time series representation of how many people were posted in the aftermath or lead up to particular events related to Black Lives Matter. For instance, the initial Ferguson protests, we see 1.5 to 2 million tweets per day. After the death of Michael Brown in late November, early December of 2014, we see almost 3.5 million tweets per day after the police officer Darren Wilson, who shot Michael Brown, was not indicted. This gives us a very different kind of view about which events are driving a significant amount of engagement or a significant amount of public attention about a given event. Likewise, this is another representation of time series data about earthquakes and how people are talking about earthquakes in Mexico. There's a lot of good work showing that social media's response to earthquakes gives you a lot of insight into the severity, reach, and location of an earthquake. This one is in Mexico. There's some of the initial work done in this area was by a group, author Sakaki and his colleagues in Japan. Japan is a very densely populated area, and they found that being able to predict the time series data from Twitter about earthquakes in Japan actually moved faster than, or gave them a lead on predicting earthquake propagation through the soil. So this time series data is also really valuable. Other kinds of data we can look at. So this is my Twitter account. We see I have self-professed my location to be New Jersey, New York, and DC, whereas a friend of mine who runs this account for her golden retrievers, the golden ratio, she is in the Florida Keys. You can use this information to identify where people are in the world, so modulo some strangeness in how people fill these location pieces of information out. But it turns out you can use this information to understand a lot about the world in terms of population density, population movements. It's a very nice visualization on the right about where most people are tweeting from and what kind of hashtags are driving the different populations of tweeters. This is all what we call geolocation data. There's a whole area of work on doing geolocation. So the two examples you see on the left are geolocated individuals, but you can also geolocate messages. I could be, just because I live in DC, I could be traveling abroad and post a tweet from a particular town or country that is not where I generally am, and you can geolocate content as well. It turns out Facebook and the Facebook Data for Good organization has used this location information in the United States and globally to track how people are responding to the COVID-19 pandemic, which states have people staying home versus which states have seen changes to their mobility patterns, which is useful for public health officials if they want to understand, like, how am I doing relative to other states, or what counties in my state are more or less likely to have less propagation or less spread of these public health issues. As mentioned when I was talking about surveys, we also are particularly interested in the latent factors about these people who are using social media. So their gender, age, race, income, community, education. All of this can be valuable information for a number of different kinds of questions. So this is all demographic data. Now, some of this is if on Facebook, a lot of this information is shared. People tend to share their age, their marital status, their political affiliation, and religious affiliation, but on other places like Twitter and Reddit, this is very much not the case, or not the norm. But we want to potentially understand that information as well. We talk about trying to understand the platforms. We can also look at what content is recommended. So on YouTube, that means what content is YouTube thinking I would like to enjoy next. This is recommendation data. We see this in Twitter as well about who you should follow. Facebook is a similar friend suggestion or people you may know listing. And then we can look at advertising data as well. So I've already mentioned with the ProPublica Chrome extension, looking at Facebook political ads. Facebook has since released the ad library where they can show, or they are showing spending for political for political campaigns. Here's a set from the U.S. presidential race, but it's not just specific to the U.S. This is an excerpt from the BJP's page and the ads that they're pushing or ads that they're purchasing in India, and how many people are being reached and how much is being spent on particular ads. This is useful information to understand what topics or policies are being pushed or what their platforms are by these political parties. Okay, so now we've talked about questions that we want to study about social media. how we get access or how we observe data from social media, what kinds of data we can observe. Now let's talk briefly about some important characteristics of this data. So the two main things I'll talk about are temporal characteristics. So I've already mentioned time series data. This is not what we're talking about here. Instead, we'll talk about static data versus data streams. This is a different kind, or a difference in how you collect data, or what your whole sort of paradigm is about how you deal with data sets. And then two is persistent versus ephemeral data. So I'll talk about what that means in a minute. First, in terms of static data versus data streams. So static data, when we are doing collections in social media, you may think of, well, we have data on Facebook, we have data from Twitter and Instagram. We're going to do a big collection task, and we're going to store all of this in a database. And then once we've stored everything, we're going to process it. That's perfectly reasonable, but we have to understand there's some limitations here. But the idea is we have all of this data, maybe it's everything that's been posted up till today, and then we're going to process it somehow. Now, we know that this is imperfect sort of representation. So on Twitter, we know, so here's a tweet from 11 hours ago, followed by a tweet from 6 hours ago, and some responses and some even more recent tweets. So what happens for these static data sets when we know that, well, if I stopped collecting 12 hours ago, I missed all this content from the most recent 12 hours. Why did I stop collecting 12 hours ago? So these are questions we have to ask. But if instead we look at this, well, we're not collecting data sets and then storing them and then processing them, we can look at it in terms of collecting streams of data. So if we know that data is always coming in, it's going to be streamed towards us, we have to deal with a sort of unbounded set of data. How do we do things differently? And this is often a real-time task. So data is coming at us right now. Maybe it's new tweets that are being posted. Maybe it's new click logs that are being collected from Amazon or people browsing your website. Or maybe it's sensor data from who knows what. The point is, this is data that's coming in generally pretty rapidly, and content that we know we can't just stop collecting and then do some analysis on, because then we'll miss things. But the key here is there's potentially unbounded growth. There's maybe no end to this data. What do we do in that case? So this is the context for streaming data, which necessitates new approaches to how we handle analytics. So first, you have to answer the question about, like, does old data matter? So depending on what the task is, if I'm collecting tweets from the past 12 hours, or I'm streaming in new tweets about a particular event or new tweets related to earthquakes, does a tweet that I posted 12 years ago have any difference or make any difference about this content? And the answer is maybe not, if I'm trying to understand what is actionable right at this moment, but maybe it does if I'm trying to understand evolution of a particular user. So these are questions that don't have a clear answer all the time, but it's a question that we have to deal with. And then there are other things we get to change about how we store stream statistics. So if we're talking about storing all data and then processing it, what does it mean to to calculate the average number of tweets per account, or the average number of images per post, or something like that? For the static data set case, we just count up all the number of images and divide by all the number of posts, and we have that value. If we want to understand this same value, but in the streaming sense, it doesn't make any sense to have to recalculate all of these different counts all the time, or anytime somebody wants to ask this question, because the data can potentially change from when I ask this question versus when you ask this question 20 minutes later. And that means we'd have to store all the data and be able to analyze all that data in a way that might be computationally infeasible. So there are other ways of calculating calculating summary statistics for streams that allow us to not have to go through and recalculate or reevaluate the entire data set to do so. We'll talk about this more over the rest of the semester, but I bring it up here because when we talk about APIs, Twitter in particular has different approaches to their APIs depending on which kinds of questions you want to ask. Also, for now, we can make things easier on ourselves by treating data streams like static data. There's not a huge amount of difference here if we want to pretend that we have static data. So for instance, you can take a stream, we can collect for 24 hours into some database, and we say that's our batch, or that's our whole data set, and we do some analysis on it. Then we collect for another 24 hours, put that data into our original database, and now we say, well, that's our data set now. We do some analysis on it, and you keep doing this, and you keep doing this. And maybe this is valuable. I actually have some colleagues who work for an emergency management organization who do social media analytics this way because they don't have the bandwidth to constantly be reevaluating or updating models. So instead they do this sort of stepwise collection where they collect for some amount of time, do some analysis, collect for some amount of time, do some analysis. And this is also a legitimate way to deal with reduce the complexity that comes with streaming. But we lose aspects of how some of the data works. All right. The next thing is persistent versus ephemeral data. So traditional social media platforms like Facebook, Twitter, Instagram, Reddit, when you post to that platform, there is an expectation that that post will remain on that platform until I delete it or until something happens on the platform. And for a long time, this was the big concern that people had about posting on social media, that that picture of you at a party from 10 years ago is going to come back to haunt you. This overwhelming massive data and potentially collection of information that people don't necessarily want to be stored resulted in a sort of new approach or a new kind of platform coming out. This is ephemeral platforms. So Snapchat is the sort of premier one, where I take a photo, I post it on Snapchat, and it will not stay. It is intended to expire or be deleted or self-destruct in a way that content from these more traditional platforms is not. Snapchat has this. It's sort of the main affordance of the platform is that a piece of content you post to the platform goes away. Instagram stories are very, very similar. In fact, there's some political aspects here about how Instagram potentially stole the story idea from Snapchat. 4chan works similarly, where content that is not highly engaging expires or becomes stale off the platform, and only content that is the most engaging stays around for a long time. But even then, the anticipation is that content eventually goes away. So the key here is that ephemeral data is meant to expire. The key affordance is that if I post something on an ephemeral platform, the default is it will go away unless I do something to change that. Same way Facebook now has stories, Instagram has stories, but the general default if I post to one of these more traditional platforms is content stays until I delete it. For something like Snapchat, content goes away unless I do something to keep it. Now, this has important implications for how we collect data. So with Twitter, potentially if I 6 years from now decide that the 2016 and 2020 elections were very interesting and I want to collect data about them, even if I'm somewhere far in the future, there are some issues with that, but we could still potentially go back and collect data from the timeframes of interest. This is a thing I run into with the crisis informatics work I do, where we want to look and see how people are posting during natural disasters. So we look for times where natural disasters happen and collect data during that time. But for ephemeral data, we can't do that because data is meant to expire, which means the only real way, or potentially the only real way to collect ephemeral data is to collect it in a sort of real-time stream processing way, because otherwise it goes away. And that puts a pretty significant burden on the collection, and maybe we have to collect way more data than we ever really need, but maybe that's the only reasonable way to do it, knowing that the ephemeral data will eventually disappear. Which leads us to another ethical question. If a user is actively choosing to post on a platform that provides this ephemeral affordance, we as researchers, if we collect this data and we keep it, does that violate this expectation that the user has that data is going to go away, that data will self-destruct? Ostensibly, yes, but in terms of the platform, maybe it's the only way to collect the platform. So questions, again, that we have to wrestle with. So we've talked a lot about the kinds of problems. We've talked about the kinds of problems we're interested in. We've talked about the kinds of data we have, where we can get that data. Now let's talk about the kinds of problems we may encounter with that data. There are two main questions here. What data might we miss? And what data might we oversample or get too much of? Really, this is a question of bias in our data, where we know that social media data is biased. It's not a representative sample of the world, and we can very clearly see that here from this graph. So in this case, who are we missing? We're missing large segments of the elderly population. They're very politically active. They have particular needs that are different from the needs of the 18 to 29-year-old age bracket. So we can't just make broad generalizations about Americans based on data on social media. Likewise, we know that not everyone is on one particular platform. So even of the majority of 18 to 29-year-olds who are on social media, most of them actually aren't on Twitter. In fact, only about 1 in 5 to 1 in 4 people in the United States are on Twitter often. And that means that even if we're looking at one platform, we can't make broad generalizations about the population, even if we had access to that full platform. Same thing with Facebook. We'd get the majority of Americans, but not everybody. So in that case, we're still missing people. Looking beyond the United States, we see this issue is prevalent globally. If we look at Twitter for doing things like public health prediction, this may work in the United States, or public health forecasting for the flu or something, this may work in the United States. Maybe it'll work in Japan. Probably won't work in Malaysia or Colombia, who are down towards the bottom of this graph. So in that case, we're missing potentially large portions of those populations. Now, partially this is driven by differences in national populations, but when we're talking about there are only 17 million people in India who are on Twitter, and India is a much larger country than the United States, then we know we're missing people. We can talk about missing people in other ways as well, not just geographically or globally, but also who is actively incentivized not to use the platforms. So here we've already talked about, 4 in 10 Americans experience some kind of harassment online. This is especially true or especially impactful for people of ages 18 to 29. I don't have the stat here, but it's also much more impactful for women, because women are more likely to experience stalking or intense sexual harassment, whereas men are more likely to experience offensive name calling. So this is very different sort of behaviors about what genders are going to be represented on the platforms. And a good example of other kinds of differences is the story from last year about the Democratic electorate on Twitter, and how the Democrats who are on Twitter are very different, or a very different sample of the population than your average Democrat in the United States in terms of the policies, their age, their demographics. It's a very skewed set. So we can't just look at social media and know or make suggestions about the larger population unless we do something to address this question of who are we missing. That's not to say that we have done something wrong here, because we can still study these populations. We just have to be very clear about our population under study are those people who are on these platforms, and we know that that's not representative. Some good examples of this, or a fun one, is XKCD's pet peeve number 208, where if we're looking at geographic maps, here we have the heat map of people who are using a particular site, those who are subscribing to Martha Stewart Living on the right, and consumers of a particular niche kind of adult content, and all the maps are very similar. Here, this is a different kind of bias where we actually are not capturing any meaningful difference between these three different populations. Really, all these different maps are driven by population distributions geographically. And if we don't take those into account, then we're doing something wrong if we're trying to make an inference about population differences here. There's a whole area of research on this. In fact, especially now, there are whole groups of organizations or whole groups at large tech companies dedicated to this. So Microsoft has FATE, Facebook has FAIR. FATE is Fairness, Accountability, and Transparency in Ethics and AI. There's a really good quote from Alexandra Oltanu, who's there, about how you cannot fix bias in data. There are all kinds of bias in data. These kinds of questions about who are we missing, who are we overrepresenting, that's built into the data. We just have to find ways to address it in some way, or at least acknowledge it very clearly in places where we cannot address it. So this brings us to the question about how do we draw inferences in this case. There's a technical question here. In fact, there's a huge area of research around this technical question of how do you correct for bias. Sometimes you can, sometimes you can't. Here, what I mean is the ethical question. So if we know that our results are going to be biased in some way, which means we know that they are wrong in some way, how can we justify making inferences that we then act upon? These are important questions that we have to deal with. All right, so everything that has led up to now has primarily been more theory-oriented. Now let's talk a little bit about the practice of collecting data from social media. I'll talk about a few different APIs for this and walk you through doing that, or walk you through getting to the point where you can do some collection on your own. So primarily we'll rely on some RESTful APIs. I'll show 4 different platforms: Reddit, Twitter, YouTube, and Facebook, and I'll walk you through some of this. So the data acquisition process generally looks like this. We have some platforms. We want to collect data from them where they provide a RESTful API so we can access data on them. And we want to take data from those platforms and store it in some database or some collection that we can then analyze later. So generally the first step here is you get some API package. Now maybe this is some library offered in Python or Ruby or R that provides a nice wrapper around the API. Or it could be some utility like curl or requests library that allow you direct access to the API for doing web requests or REST requests. It could be either one of those. Then you have to register for the API. So generally these APIs come with some kind of registration or authentication mechanism, especially APIs that allow you to operate on behalf of a user. Those all have to have some kind of authentication mechanism. And this is also used for rate limiting. We'll talk about that more later. But a lot of these APIs have some kind of rate limit built into them, so they prevent single users from overwhelming the bandwidth of the platform or taking more than their fair share. Once you've registered for the API, then you get keys for the API. These are essentially authentication mechanisms like passwords, very similar, that allow you access and identification of who you are, what user you're acting on behalf of, these kinds of things. And then we can send these API requests with a signature or signed with these API keys that we have. Before we get too deep into the mechanisms for doing collection, I want to say a few things about the kinds of data that you will expect to get back and how we can understand what responses are going to be. So first, we'll talk about parsing API responses. So this might be a typical API response from Twitter, where we have a bunch of these, you start with these curly braces and then a bunch of these sort of quoted strings and a colon and then some more curly braces. But first, so what is a REST API? What does this mean? So REST stands for Representational State Transfer. API is an application programming interface. And together, this is some sort of interface that lets clients access some kind of model for the data that's being made available. And generally, this is stateless, meaning you don't have to have some sort of sequence of queries or sequence of calls to get the data. All the information that you need to fulfill a request from the REST API must be encapsulated in a single request. What do these requests look like? So generally they're requests sent to a particular website. The important thing is often they are making use of the HTTP protocol or the general web protocol. They can be HTTP or HTTPS. Sort of irrelevant there. Then there is a host name for the server that provides the API. There's an API entry point, which means that all points of the API must go through this or include this API part of the URL. And then you have examples of API endpoints. So here, imagine this host name was providing tweets or information about users or information about other things. All of these 3 things are API endpoints. And you can have other kinds. You can certainly have nested endpoints. It doesn't have to be at the end, but you could have API tweets lookup or API tweets post or something like that. Those are all potential endpoints that give you access to tweets in some way. This is actually an example from Twitter's most recent API, where we have the web protocol. Notice it's HTTPS for security. We have a DNS host name, which is api.twitter.com. We have the API endpoint, or entry point rather. This 2 denotes that this is the second version of Twitter's API. We have the API endpoint for tweets, and then we have parameters for the API request. So this might have headers that include the credentials or API keys. But here this says we want the tweet with the ID of 20. We want to include the created at field. We send this to api.twitter.com via an HTTP GET request, and then we get some response. Now, this is what that response may look like. That's not actually, this is a response from Reddit, not from Twitter, but we see there's potentially a bunch of data here. This REST API output generally comes in the form of JSON, or JavaScript Object Notation. And we can see this very easily if you go to Reddit and you go to any post in Reddit and take the www out of the URL and replaced it with API. Then we see you can get back the JSON that represents that post or that object on Reddit. You see there's lots of content here. So this content is in the form of JSON, as I mentioned. So how do we parse this, or how do we make it easier to read? So here, this is a very nice sort of pretty printed version where we see these keys, contributor, truncated, text, ID, etc. are nice in blue, and the values are in green, or they're nested, or have better tabbing if they are, or indentation if they're sub elements of these keys and values. So what JSON is this kind of format. So it's generally just a text version of a dictionary structure. So that's actually where it gets the JavaScript object notation. JavaScript has objects. Objects are generally some sort of key and value. They can have additional things. JSON here generally is sets of keys and values, or key value pairs. The nice thing about JSON is it's similar to XML, but less structured. So XML used to require a pre-specified schema for doing like schema validation, and you would have the XML file itself that would then refer to that schema, and that schema would say, well, if you have this key, you must have this attribute, or these kinds of things. With JSON, you don't need that. It's much more flexible. It's different than CSVs because it doesn't require the sort of flat structure that CSVs have, where CSVs are generally just rows and columns. JSON can have like arbitrary nesting, as you see here, with like, say, this hashtag part where we have hashtags, which is actually a list, all the hashtags that show up in this tweet, and each object in this hashtag list has an indices. That's where in the text it occurs, what the text of that hashtag is. Same thing with user mentions or points, these kinds of things. So you can have arbitrarily nested content here. Oftentimes, this format's used for data exchange or storage or serialization, primarily because it's easy to parse in this way. Python actually has really good support for JSON already with the JSON package that's built in. It makes it very easy where you have some string that includes your JSON. All you got to do is call json.loads. That S at the end means string, and it will parse this JSON and give you back a dictionary where the key in the map gives you back the value associated with that key. So we use this library a lot. I'll note there's a slightly different kind of JSON that I make use of a lot called new line delimited JSON. So generally what JSON expects is a full file that has all the JSON content as one large JSON object. Oftentimes with tweets, this doesn't make any sense because we have a bunch of tweets. Each tweet is sort of its own JSON object. So instead we store these as lines, where a single line in a file is a full JSON record. Now what this means is you might have some file like test.json where you have key, value, data, and then a new line, and key, value, 2, and another set of data. If you just call json.load and try and read in that whole file, it will fail. This actually is sort of a pseudocode kind of example because json.load expects a file pointer rather than a file name. But if you load in the full file and try and read it as one JSON string, it fails. Instead, you have to parse through or iterate through every line in this JSON file and load it in that way. The last thing I'll say about JSON is how to get this nice, pretty kind of output. In Python, you can do this by the json.dump or json.dumps function has an indent argument that lets you do indentation. This is actually rendered by a tool called JQ, which is easily available on GitHub, where you can pipe content into JQ and it gives you this nice coloring and indentation. So I highly recommend installing that. It'll make things easier. All right, the first API we'll talk about is Reddit. I'll go through the 4 steps of getting an API package and getting us down to sending API requests. The most well-known API wrapper for Reddit, I think, is PRAW, the Python Reddit API wrapper. It's a very simple wrapper and it has a lot of good documentation about how to use it. You can get it from GitHub or you can get it directly from the Read the Docs website. There's also an R client called RReddit by Matt Kearney, which is also a very good package if you have a preference for R instead of Python. All right, so how do we get access to the API? How do we get to the point where we can register? So if you go to reddit.com, this is the new version of Reddit. You want to go to user settings. Then you want to click on the safety and privacy version or safety and privacy tab. Scroll down and you'll find at the very bottom this manage third-party app authorizations page. So you click that and it takes you to this page. Yours will be a little bit different. So I already have a test application here, but you want to create your own. So if you click that, create another app, and then here under create application, you want to give it some unique name, read the API usage guidelines to get familiar with them. You want to select web app, give it a description, and you want to give it a redirect URI. You can leave the about URL blank. The redirect one will not use it in this particular version, but the redirect URI is useful for having other users authenticate this application on their behalf. So you could write this app, and then if some user wants to use it, it'll pop up a Reddit website. This is would you like to give this application access to your account? And then once they click yes, it goes back to this redirected URI. We will not use that here. All right, so once you've filled all that out, you click create app, and now you have a new app. That's the one that we are going to care about. And there are 2 keys here that are important. There's the web app key right here, and then the secret. You want to copy those out because we'll keep them for our script that'll actually read in data from Reddit. Okay, so you can go check out examples from the PRAW website. I'll also provide you a JavaScript notebook, a Jupyter notebook with examples about how to deal with the Reddit API. So if you scroll down a little bit, you'll find this block here that says now we specify our user agent and our client ID and secret. So then you just paste in the client ID and secret that you copied out of the Reddit website, and you want to specify some unique user agent to identify your application. And then once you've done that, you can use the Reddit API from PRAW to do all kinds of things like get the 10 newest submissions to the World News subreddit, or the 10 best submissions to a particular subreddit of interest. I'll leave what exactly you do with that sort of up to you. All right, so that's Reddit. The next one we'll do is Twitter. I'll note that Twitter is a little bit more sophisticated than Reddit in its API. There's a lot more options here. So I'll try and keep this quick. The main thing is you need to have a Twitter account. Like with Reddit, you need to have a Twitter account in order to access the API. If you go to developer.twitter.com, you can log in and set up your developer account. Before we get to that, though, a note on the API types. So in Twitter's API, as I noted, there's a search API. So this is the retrospective search as opposed to the streaming context that we talked about earlier. But there's also 2 parts of the streaming API. So there's a filter API and a sample API. So filter real-time tweets is a streaming endpoint, as is sample real-time tweets. So the filter lets you specify a set of accounts or a set of keywords or a set of locations like geolocated places and collect new content that's posted to the platform that matches your query essentially as that content is posted. The sample real-time tweets endpoint is a random sample of 1% of Twitter that is made available by the platform. As that content is posted, it goes directly to you. It gets pushed to your client, where you can then collect it or analyze it or do something with it. Whereas the search API or the get tweet timelines APIs are all purely retrospective. They look backward in time rather than streaming. All right, so the API package that I use a lot of, at least in Python, is called Tweepy, which has a lot of good documentation about how to engage with the Twitter API. You can get it at tweepy.org. There is an R wrapper as well called rtweet. It's, I think, the most recent one, more popular one that I mentioned. So how do we register for the Twitter API? So I've already mentioned, go to developer.twitter.com. If you haven't signed up for Twitter already, you want to sign up. If not, if you have signed up, you want to log in. If we want to access the Twitter API, you're going to come to this page. You want to identify that you are going to use the Twitter developer tools for research or for being a student. It's here on the right. Then it'll ask you some questions about who you are. If you don't have a valid phone number associated with your account, you'll get an error message here. So you want to make sure that you have that phone number. This is to prevent people from creating arbitrarily large numbers of accounts. It's very easy to create email addresses. It's more difficult to create phone numbers. And then once you've gone through those steps, you now get access to the Twitter developer platform to create an app. In the same way that you create an app for Reddit, we'll create an app for Twitter as well. So you want to give it some name. Once you do so, the website will give you this sort of example here with a set of API keys and a bearer token. I'll tell you in a minute what a bearer token is. But for now, we can if you go to test this endpoint, here will give you some examples. So if you click one of these sample tweets, like here, I clicked on this first tweet from Jack, who is Jack Dorsey, the creator of Twitter, back from March of 2006, where he created his Twitter, or setting up his Twitter. On the right, you see this curl request with your bearer token that you can run and get some JSON response back that includes information about that tweet. You can do so with the Ellen DeGeneres tweet and a few others as well. All right, so once you've finished the demo there, you go to the developer portal. If you've opted in to use the newer developer portal, this is what this looks like. Note that the app you just created is under projects. And if we want to get more information about the keys, we want to click here on keys next to the app. And there are a couple of keys that you'll get access to. There's the API key and secret. So that's generally associated with your particular app. So that'll change by app. You can regenerate it or you can view them. Note that if you regenerate them, whatever keys you've stored elsewhere associated with this app stop working. Then we also have bearer tokens and access tokens and secrets. The main difference here is that a bearer token allows the API, or allows your request to make requests on behalf of the application, which means that it cannot create content. It can only consume content. Whereas the access token and secret are associated with a particular account. So here in this case, if I were to create an access token and secret, it'd be associated with the Twitter account that I created for this, the Infico account, which is my lab. If you do this in your personal account, it will associate an access token and secret for your personal account. The important thing is here, having an access token and secret allows you to post data to Twitter. If you use a bearer token, you cannot create data, you cannot post data to Twitter. But if you want to build a bot or something like that, then you would have to have an access token and secret. Tweepy supports both of these. All right, so once you get your keys, then you can run some of these examples. So the bearer token, be sure and replace the angle brackets on either side of bearer token. You can run this. Here's an example that I ran with the output it got using the API, the REST API command that I showed you before a little bit. We have api.twitter.com/2/tweets. We want the ID tweet for the ID of tweet 20. We want when it was created, and we want to expand some author information about it and when that author was created. So then we get this JSON data back that you see starting with the curly brace, data, text, etc. If we pipe this data into JQ, we get a much nicer sort of pretty printed version where you can see username Jack, name Jack, and when it was created. Looks like Jack's ID, his user account was the 12th created one, and this tweet was the 20th tweet. And as I mentioned, JQ provides a nice pretty printed view of this to make it easier to read. As with Reddit, I'm providing you with a notebook for dealing with the Tweepy package and collecting data from Twitter, so you can do some examples here. One additional note about Twitter and rate limits. Reddit also has rate limits, but Twitter's rate limits are something you're likely to encounter. So what is a rate limit? A rate limit is something that is a limit on the number of times you can request content from Twitter before you get an error back. So here on the right with the Twitter version 2 rate limits, we see that you have, for every 15 minutes, you can call the tweets lookup endpoint 300 times if you're using a bearer token, or 900 times if you're using the access token in secret. Same thing with user lookup. Recent searches are a little bit different. The 1.1 version of the API has a similar kind of rate limiting structure as well. Note the differences on the left and right of the screen are generally about, on the left we're seeing, I showed you the rate limits for posting. You have to scroll down on that page for the rate limits for data collection. But you need to, if you start running into errors with your data collection, it's likely to be a rate limiting issue. There are two issues for this. One is you can actually make requests to Twitter to see how long you have until your rate limits refresh or reset. And then you can wait that time. You can call it time.sleep or something to wait until that time has passed. Or specifically in Tweepy, Tweepy has a nice argument when you create or connect to the API called wait on rate limit. Now, by default, this is set to false, but if you set this to true, the system or the package will automatically check your rate limits and will pause and wait for you when you reach a rate limit. So this is a useful thing to know. All right. Now, as I mentioned, you don't need the Twitter API. There are packages for scraping Twitter. In fact, you don't need the Reddit API for the R package as well, because when I showed you that replacing the www.reddit.com with json.reddit.com or api.reddit.com, you get direct access there to JSON that you can then parse. Twitter has the Twint package that lets you scrape. There's also a Twitter scraper version built on Scrapy that lets you scrape data from Twitter. Maybe you need to do this if you want more than, or content that's older than the most recent 3,200 tweets from a particular user, which is the limit that you can get back from Twitter through the API. Here's some examples from Twint about how you use it. You can call twint-u for username and make requests, or twint-s for a particular string query, and you can get data back this way. You don't need an API key or anything like that to do this, but note that it's all retrospective. You don't get access to the streaming API using Twint. So only retrospective search here. All right, YouTube, I'll go through this pretty quickly because I don't have an example for YouTube other than the YouTube developer examples. Note that YouTube is part of the larger Google ecosystem, right? So everything here is sort of built on access to Google. You can access it through developers.google.com. There's a lot of code samples and a lot of nice resources for developer resources for the YouTube Data API. The main one we'll use is YouTube Data API version 3. There is a set of wrappers in JavaScript, PHP, Python, Java, most languages that you may need. And there's a YouTube Data API wrapper package made available by the Center for Social Media and Politics at NYU. Here's their link to the GitHub repo for this. I've used this a number of times in the past. All right, so to register for the API for YouTube, as I mentioned, it's part of the Google ecosystem. So you want to go to console.developers.google.com, which shows you a nice page like this. Here you see where it says Reddit Analytics for me. That's actually a per project name that you can provide. So you can do some set of analysis in a YouTube project or or some other project for access control, so however you want to group them. Note that the rate limits that come with the YouTube API are per project here. So if you need more requests, or if you are running up against a rate limit, you can spread your requests across a number of different projects, but there's a limit on the number of projects you can have. All right, so I created a new project called YouTube version 3, and I want to enable some APIs for it. So you click that, and then you search for YouTube, and you get a set of APIs back. We care about YouTube Data API version 3. You'll come up with this. I've already enabled it, but you want to make sure it says API enabled. And then once you've done that, we want to actually get keys for them. So you click this 3 horizontal bars here, click on credentials, and you get this list. Note, I already have an API key, but we want to create new credentials. Click that, you get API key, and you get your new API key here. And then that's all you need. So once you have that key, you can copy it out and install the YouTube Data API package and put your YouTube API key there, or use requests or curl or something like that to make requests using that key for you. And then you can start collecting data about channels or comments from YouTube or recommended channels. There's a lot you can do with the YouTube API. But I'll leave that sort of up to you. All right, the last API that I'll talk about is the Facebook one. The Facebook API is a little strange, so they've gotten a lot of flack over the past 4 years after Cambridge Analytica and a number of these other big leaks. So now, in order to use the Facebook API, you can only use it on your account or on pages that you own, unless you go through a number of additional bureaucratic hoops that are very hard. But Facebook does provide you with the Graph Explorer, which is a nice little interface where you can see what the Graph API that Facebook provides would give you. So you can go to developers.facebook.com/tools/explorer for that. If you want to do Facebook analysis, though, I'd recommend you look at CrowdTangle. I have access to this through their academic hub, where we can get access to public pages and public groups on Facebook. Not comments, but we can see like what Joe Biden or Donald Trump or Theresa May or some public figure on Facebook has posted to their public page, and how many people responded to that. We do not, like I said, we don't get their comment data. We can at least see engagement metrics. CrowdTangle also has a Chrome extension that you can play with that lets you get engagement with particular URLs. So here, if you go to crowdtangle.com and install the CrowdTangle Chrome extension, it shows you how many times crowdtangle.com has been posted on Facebook, Twitter, Reddit, and Instagram, how many interactions it's had, when it was posted, in a number of different places. When you click the CT icon, a good example here is the COVID dashboard from the CDC, where if you go to covid.cdc.gov and then look at this on CrowdTangle, you can see that it was posted 177 times to Facebook. Primarily, it gets a lot of its engagement or interaction from the CDC page, but also strangely from this what appears to be Chinese page. If you go to Twitter, you see that there's a lot of interaction from this person named Phil Kerpen. At the bottom, you see the DNC server. It's probably a conspiracy account. Likewise with Reddit, most of the places this link has been posted seems to be r/conspiracy, which is concerning. But you get a sense for where this content is being spread and how many interactions it has. So while I've only mentioned Reddit, Twitter, YouTube, and Facebook, many of the online media platforms or online social media platforms have APIs that you can use. Twitch has one, LiveJournal, Instagram, Foursquare, Flickr, Tumblr, TikTok. All these different platforms have APIs. There are differences in the level of documentation that are available to you and what sort of hoops you need to jump through to access them, but they're all generally available. So if you want to look at some of these other platforms and do collection there, you are welcome to do so. But now you've at least seen the general kind of workflow for how you might access these platforms. Last, there's an interesting movie on Netflix called The Great Hack that might be of interest to you. It could be a good opportunity to do your ethics presentation on this. Watch the movie and then give your class a summary of the movie and what you thought was interesting or compelling or concerning about it. But it's all very relevant to the kinds of stuff that we've been talking about. So that's it for this module, and Note that this will kick off, or this week starts the kickoff for your assignment 1, your first Real Medium blog post. If you have any questions, feel free to reach out, and I'll be posting some of the discussion questions from this class on the discussion forums as well.